Well, thank you, Christoph, for organizing such an interesting event and bringing together some of my favorite people in the field that I haven't, especially those I haven't seen for a while. So thank you. I'm still on Toronto time, so I should be wide awake, but we'll see how it goes giving a lecture in the evening. I hope I'm going to be intelligible for everyone. So as we just heard from Dennis, biology is today arguably in the midst of profound changes. A rethinking of our conceptions of organisms has arisen in the face of new studies of their capacities to respond adaptively to genetic, epigenetic, and environmental affordances. A reductive focus on molecular mechanism and population dynamics has been increasingly found to be inadequate to account for the distinctive organization, modes of self-reproduction, and vital functioning of living beings. How to cognize life has become an open question. This question takes on new valencies in the context of a fundamental reevaluation of the mandates for universities and the traditional structures of disciplines, in the context of extraordinary cultural and political upheavals, and in the context of pressing environmental crises and climate change. The questions, what is life? And how are we to understand living organisms and their relationships to the larger natural world have increasingly cognitive but also ethical significance. In addressing these issues, philosophers and biologists have turned to the history of their disciplines in their search for alternative conceptions and approaches. A turn to the past need not be regarded as an adoption of outdated science or explanations, but the exploration of promising orientations left undeveloped or forgotten that might provide a stimulus to current rethinking. Our perspectives on the past change with shifts in our present critical commitments. Science is particularly subject to such historical reassessments. It is necessarily historical, subject to profound transformations as well as continuities of development, to wide divergences as well as narrowed foci, to inclusions and exclusions. As the presence of science shifts, as its subjects matter, its methods and theories change, so do its relevant paths. The history of science shows how, repeatedly, subsequently discredited methods and theories discredited others in their time, and thus that many present commitments will in turn be discredited. Present critical studies of natural science also re-examine what science is, has been, or might be, questioning the representations of science within scientific communities and their publics, both in the past and in the present. Questions of relevance are thus complicated by shifting critical perspectives and accompanying historical reassessments. The question of what is life has been repeatedly asked in the history. Oh, I don't seem to be advancing on my PowerPoint. Sometimes that happens when you share screen. There we go. So this is an interesting volume, a new collection by my colleagues Stefan Helmreich, Natasha Meyer, Sophia Roos, and Michael Rossi, with contributions from the late Evelyn Fox-Keller. And it's a small little volume, but they found, they published together with small essays, title pages of this question, what is life, asked repeatedly throughout history. And I've just given a few examples there. The turn of the 19th century is an important juncture in that history because of attempts at the time to establish a science of biology and to explore in depth what demarcated living from non-living beings. The German physician Gottfried Reinhold Treviranus offered the first extended exploration of such a project in his Biology, or Philosophy of Living Nature for Naturalists and Physicians, appearing in 6 volumes between 1802 and 1822. The question what constituted life or a science of life was also addressed by philosophers and romantic thinkers, from Immanuel Kant, Johann Wolfgang Goethe. The University of Tübingen played an important role in these developments. Today, I will focus on 2 of its most famous scholars, the physiologist, naturalist, and chemist called Friedrich Kielmeyer, and the philosopher Friedrich Wilhelm Joseph Schelling, both of whom contributed to our rethinking of the understanding of living organisms and the foundation of the science of biology. Although Kielmeyer published little, his lectures were widely circulated and discussed. Goethe sought out Kielmeyer personally and asked for copies of his lectures. The Jena professor and Kantian philosopher Carl Schmitt praised him in his 1798 Physiology, philosophically prepared, and Alexander von Humboldt dedicated his 1806 Observations from Zoology and Comparative Anatomy to, I quote, the great physiologist Friedrich Kielmeyer. The Tübingen Stift associated with the University of Tübingen was where Schelling came of age in the early 1790s. Oops, getting ahead of myself. As a roommate with fellow students Carl Georg Hegel and Friedrich Hölderlin. Both Kielmeyer and Schelling benefited from the patronage of Karl Eugen, Duke of Württemberg. As was common practice in the latter half of the 18th century, the Duke supported the education of talented young men from poor families to produce state servants to advance the economic life and administration of the duchy. Kielmeyer's father was a forestry official in the ducal government, and Kielmeyer was initially trained in natural science at the Karlsschule in Stuttgart with the view that he would follow in his father's footsteps. But excelling in his studies, Kielmeyer went on to complete a medical degree at the University of Göttingen and then returned as a professor, first at the Karlsschule in 1793 and then at Tübingen in 1796. The Tübingen Stift was similarly intended to train young men to serve the duchy, churches and schools. But like Kielmeyer, through his schooling, Schelling advanced to the position of professor of philosophy at the University of Jena in 1798. Before turning to a consideration of Kielmeyer and Schelling's contributions, it's worth pausing to remark on the sense of both promise and limitation that young scholars faced at the turn of the 19th century. While many young men benefited from the opportunity for advanced schooling, very few followed the trajectory of Kielmeyer and Schelling. Many toiled as administrators in small towns and duchies. Others only secured positions as tutors of disinterested children of minor aristocrats in provincial backwaters. Remaining impoverished, isolated, and overeducated, many were frustrated by the limited career opportunities their education provided. Moreover, at schools like the Tübingen Stift, patrons often impose a very conservative program of study and strict discipline. Schelling, Hegel, and Hölderlin found the atmosphere at the Stift stifling. Students were exposed to Kant's new critical philosophy, but that made them only more scornful of what they termed the practical Tübinger reason, that turned critical philosophy into dogmatic theology. The radicalism of Schelling and his friends was inflamed through the events in France and the support of figures like Kant for the principles of the revolution. It was in this context that Schelling, Hegel, and Hölderlin drafted the oldest system program in German idealism in 1797. Only a fragment of the unpublished manuscript remains, 2 short pages. Yet in that short fragment, so many contemporary concerns and projects were touched upon. The whole of Kant's transcendental idealism, the significance of aesthetics and poetics to the work of philosophy, the question of the relationship of moral philosophy and freedom to the idea of the world as a whole, the idea of humanity, history, and politics articulated in light of the French Revolution, the prospect of a new mythology, both rational and sensuous, reimagining the world for both philosophers and the wider populace, and the importance of the philosophy of nature and a new approach to the study of the natural world. What is striking about this document is how these young thinkers, while Kant's philosophy and new developments in science were still being digested by their generation, were already arguing for the need to move beyond them as an intellectual need and an ethical demand. Schelling, as many as contemporaries, found in Kielmeyer's work the foundations for, to quote, an epoch of a wholly new natural history. Kielmeyer is best known for his 1793 address on the relations of organic powers to one another in a series of different organizations given on the occasion of Duke Eugen's birthday. In his address, Kielmeyer set out the relationships of organic powers not only in individual organisms, but also comparatively in different kinds of organisms, and indicated how the course and existence of species of the organic world are grounded in these relationships. This lecture needs to be set in the broader context of the lectures Kielmeyer gave as chair of zoology and curator of the Natural History Museum at the Karlsruhe, as well as professor of chemistry and botany at the University of Tübingen. His research thus included comparative physiology and the history of organic forms, as well as the inorganic processes underlying organic vitality. Kielmeyer opened his 1793 address with an allusion to Kant's characterization of organized body, a characterization he'd noted was rapidly becoming the rhetorical commonplace of his generation's way of talking. Each organ of organized bodies is fitted to all the others and united in a system of simultaneous and successive alterations. Or as Kielmeyer stated, directly quoting Kant, each part becomes reciprocally cause and effect of the others. Kielmeyer then proceeded to define the primary vital powers, or Lebenskräfte, and the laws of their relations, apparently in violation of the epistemic strictures Kant had established for our judgments of organic vitality. Kant argued in his 1790 Critique of the Power of Judgment that in contrast to the determinate judgments we make regarding physical bodies through the concept and laws of mechanical science, the teleological judgments of organisms as cause and effects in themselves has a regulative status that guides rather than determines our grasp of their complex organization and self-organizing capacities. The characterization of post-Kantian studies of organic life as transforming regulative principles for judgments of organisms into constitutive concepts or substantive forces has framed historical accounts. Such readings, however, often misconstrue Kant's argument as claiming mechanical concepts or laws are metaphysically real elements of the world in contrast to the regulative concepts of organic organization. But Kant contended that both mechanical and organic concepts are a priori contributions of our understanding of the natural world. Both sets of concepts are subjective or intellectual aspects of knowledge, with the difference lying in their degree of determinate validity. What is real is the empirical phenomena these concepts made sense of. Kielmeyer made clear that he was not claiming to be able to know what these organic powers are in a substantive sense, but rather use what he argued was, to quote, the assistance of the word, the Behelfswort of powers, to name classes of similar effects perceived in individual organizations. Kielmeyer distinguished 5 organic powers: a reproductive power, irritability and sensibility, and secretion and propulsion. Kielmeyer's characterization of the relationship of organic powers drew on that of his Göttingen teacher, the renowned naturalist, anthropologist, and physiologist Johann Friedrich Blumenbach. Blumenbach was known for his work on the formative drive, or Bildungstrieb, that not only argued for the gradual or epigenetic development of living organisms, but also presented the formative drive as active, lifelong, in processes of nutrition and growth, processes of regeneration or healing of wounds, and processes of variation or degeneration in response to external environments. In his textbook, Elements of Physiology, Blumenbach also discussed different vital powers as expressions of the integration of structures and processes underlying organic functions. Kielmeyer's insistence that he used the term power to indicate similar effects perceived in individual organizations can be regarded as a kindred approach. He emphasized that he was concerned not with specifying the nature of powers, but the relationship of organic vitality, to quote, the laws and consequences of these relationships in the series of different organization or kinds of living beings. Both Kielmeyer and Blumenbach thus offered a more sophisticated understanding of organic vitality and functions than the physicians engaged in polemics over irritability and sensibility as actual organic forces in the late 18th century. Kielmeyer's most general law or conclusion was that the reproduction dominates in simplest organisms and diminishes proportionally as first irritability, then sensibility becomes more dominant in more complex organisms. He understood such laws in the terms that the philosophically informed Carl Schmitt and Johann Christian Ryle would later advocate as suited to a science of life, as empirical regularities. Such a science of life would expand Kant's restriction of the designation of natural science to mathematical mechanics, to include the empirical sciences such as chemistry and biology. From these laws, Kielmeyer hoped to conceive, to quote, the course and existence of living nature. The altering interplay of powers, the balance of powers expressed variously in the series of organized bodies, could account for the continued existence in history of organic kinds. Whereas Blumenbach's elements of physiology still followed a traditional organization of basing physiological functions on anatomical parts, Kielmeyer's emphasis on the relations of organic powers introduced a new vision for physiology based on primary organic functions such as irritability and sensibility and reproduction found in textbooks in the early 19th century. And I give some examples of books there. Kielmeyer's address presented ideas towards projects for what he termed a comparative zoology and a general history and theory of the development of organizations that he was developing in lectures and sketches. The central concern of this larger project was the history of life, the alterations occurring over the course of the life of the individual organism, the alterations occurring through the series of organizations in the history of life as a whole, and the analogies between them. In these outlines, Kielmeyer again gestured to Kant, emphasizing the importance of attention to general concepts or laws of alterations recognized through the human faculty of representation, as opposed to simply, to quote, the piling up of a great number of facts. Only by tracing the temporal relations of development can dead description become a living history and its object obtain life. Yet contra Kant, Kielmeyer argued that the investigation of development should not be held within boundaries that determine observations, as our mind does not yet know where the history of appearances will lead it. To uncover the general laws of life as a foundation of a science of the organism, it is necessary to take a leap, to quote, to foster a faculty of anticipation or a feeling for the truth developed through practice. He concluded that and I again quote, the circle of investigation becomes widened through the nature of the object itself, life expressed in various alterations. Life then is the interplay between the inner powers of the individual organism and the external world, through which each organic being maintains the material conditions of life, but by accepting and incorporating materials into the body, and is stimulated into the activities of moving, sensing, and reproducing. Of the alterations in the history of an individual life, some occur irregularly in the cycle of life, such as nourishment, the movement of blood and breathing. Others are singular, as the individual life first becomes, grows, and then diminishes. Still others are irregular deviations from healthy functions or customary development. In extending the expressions of life from the individual organism to the series of organizations, to the differential relationships of organic powers in different species, Kielmeyer set out the project for a comparative zoology or a comparative physiology. Kielmeyer made the provocative suggestion that the series of organizations are, to quote, experiments of nature, as nature makes varied attempts at viable forms of life, trying out what functions as a balance between inner and outer powers and enabling the continued existence of organic kinds. Through its experiments, to quote again, nature has reckoned with the assignment of different relationships of powers, not only with species, but also with individuals, in order to ground that economy with continuity. Rather than a providential nature aiming at specific or fixed ends, Killmeyer depicted a dynamic world in continual alteration, a creative activity producing varied living beings, some of which persisted as individuals and as species. His comparative zoology and the history of the series of organizations not only set out the laws of the relationships of organic powers, but also brought his object of inquiry to life in a living history. Killmeyer's comparative studies of organic powers can be regarded as identifying an experimental system within nature. He explicitly foregrounded the value of using nature's experiments as opposed to artificial experiments as the basis for investigations in natural history and physiology. To quote, "No artificially or accidentally made experiment has been able up to now to separate the powers acting united in the organism and to bring each acting for itself freed from its bond with the others." Over the course of the 18th century, growing evidence of the extent variation or degeneration of organic kinds had been acquired through experiments with transplantation and cultivation of plants and animals. But these experiments in natural history complicated judgments of natural forms by implicating human beings in the production of those forms and their degenerations. Concerns were expressed not only over human reason creating artificial systems of classification, but also over human hands artificially deforming natural forms to suit human purposes. Instead, Killmeyer proposed using nature's own experiments to study the extent of variations of organic form. Such comparative studies also allowed a clearer understanding of organic functions than in the highly entangled structures and operations of human physiology. Experiments that attempted to isolate distinct modes of organic vitality required interventions that disrupted normal functioning and produced conditions that were artifacts of the experiments. And people worried about these issues at the time, in the 18th century and 19th century. The vivisection of mammals to study irritability and sensibility were also widely condemned for the suffering inflicted on living beings. In Killmeyer's project, the differential conditions valued in experimental systems can be found in the series of organizations produced in nature's experiments, each of its novel yet abiding combination of powers offering a new perspective on their relationships. He proposed starting with the simplest form of life, in which modes of organic vitality are found in relative isolation. In plants, the reproductive power is the clearest, without the significant collusion of irritability and sensibility found in higher animals. In lower animals, irritability emerges most clearly, again without its confusing involvement with other expressions of powers in higher organisms. Killmeyer argued that nature puts forward experiments through the different species of organizations, which can be used in comparative investigations to arrive at a closer observation or determination of the distinct actions and relations of organic powers. Killmeyer thus regarded the varied relationships of organic powers with each other and the external worlds as indicative of a viable organic form, each a successful attempt to create functioning and abiding individuals and species in the history of life. The laws of organic powers were to name those relationships, these classes of similar effects, rather than to posit fundamental causes of life. He pursued a series of investigations exploring the relationships of these organic powers to the material and composition, the Stufenmischung, in which they were embedded. He was particularly preoccupied with infusion experiments, the apparent generation of organic forms of life from decomposed organic materials. He examined in detail the recent experiments of Joseph Priestley and Jan Ingenhousz into the appearance of green matter or algae in their chemical experiments on airs. And he conducted his own trials. But he concluded that the results of these experiments were inconclusive, but did not preclude the possibility of future success. He also conducted a series of galvanic experiments in both humans and cold-blooded animals, comparing the effects of the electric fluid produced in those experiments to the effects of nerves in other studies, although again without conclusive results. In his role as professor of chemistry at the University of Tübingen, Killmeyer examined the relationship and analogies between organic and inorganic processes without reducing life to chemistry. He concluded that organic life has its distinct form and Mischung, with organic composition a direct product not of inorganic chemical elements, but the components that chemical mixtures gradually produce in an organic body. Even in his studies of the chemistry of life then, excuse me, Killmeyer was interested in the series of organic compositions and forms which could emerge and abide. Killmeyer's inquiries into the relationships of organic powers and comparative zoology thus faced in two directions: towards nature's experiments with viable forms of life, and towards the material conditions of those modes. Ian Hamilton Grant argues, and I quote, Killmeyer's series of organizations are not the object of natural historical explanation, but the medium through which time becomes momentarily phenomenological. Grant stresses that what is important in Killmeyer's project is that species are but general representation of the continuous historical development of organic life, individually and as a whole, through ongoing processes of forming, growing, and declining, of generating and degenerating. In these processes of becoming, particular relationships of powers persist as living beings, relationships of inner functions and external stimuli, of preserving and destructing activities embodied in particular material compositions. And exploring analogies between the relationship of organic powers in the temporal development of an individual living being and the historical development of a series of organizations, Killmeyer did not propose a literal or linear parallel between the ontogenesis of an individual and the evolution of a species. Rather, he proposed an experimental system based on nature's experiments with viable modes of life. The similarities and differences of functional processes within various individuals and with a series of organizations or species across time and space in their historical and regional variations offer insight into the distinctive and combined actions of organic powers. So I'm just going to get a cough candy so that my voice lasts. In his studies of comparative zoology and general history and theory of the development of life, Killmeyer traced not only how more complex organization emerged, but also their material conditions. He traced the history of life not only into its higher forms, but also into its simplest forms in their first generation. To quote, "The history of appearances which our earth as a whole grants, according to the concept of the history of nature, must discuss not only the question of its present condition, but also the preceding and perhaps following one, and thus how it is, how it was, and how it will be. In these inquiries, identifying the laws of the relationship of organic powers is found a method for conceiving nature's experiment with viable and persisting forms of life in the medium of continual alteration and living history." Killmeyer's project for a comparative zoology and history and theory of the development of life remained prospective, articulated in lectures and sketches. Yet Schelling, along with many of his contemporaries, found within it the promise of an epoch of a wholly new natural history. The whole system program of German idealism, stimulated by the time Schelling, Hegel, and Hölderlin spent together at the Tübingen Stift, envisioned a new philosophy of nature, alongside a new approach to transcendental idealism, aesthetics, morality, and politics. I think I have a picture of the Tübingen Stift then and now, taken yesterday. On leaving Tübingen, the young Schelling took a tutoring position in Leipzig, where he was able to study the empirical sciences undergoing rapid changes at the end of the 18th century. The oldest system program was penned in the midst of these studies and suggests that Schelling's engagement with natural sciences was not uncritical. It's stated in the fragment that contemporary natural science, advancing, I quote, advancing laboriously with its experiments, could not satisfy the creative spirit of the time, and calls for a philosophy that could lend wings once more to science through its ideas. In a series of books published between 1797 and 1798 and into 1799, books on the philosophy of nature, they excited Goethe and led to Schelling being offered a position at the University of Vienna in 1798. Schelling's attempted to develop such a higher science while writing these books on the philosophy of nature. So it's important, his Naturphilosophie was not an attempt at a contribution to the knowledge of the natural world in the manner of natural science, Naturwissenschaft, or research on nature, Naturforschung. It is a philosophy of natural science as well as a broader philosophy of nature. But nor is it simply the application of abstract principles to an already existing empirical science, as he characterized Kant's philosophy of natural science. As a philosophy of nature, it was to interpret what the sciences read in nature and to allow, quote, natural science to arise philosophically. Schelling's philosophy of organic life is one of the most singular contributions of his natural philosophy. Schelling provided a host of original philosophical investigations into developments in natural science at the turn of the 19th century, from a dynamical construction of matter within a universal system of gravity, to a derivation of the principles of chemical processes and the central place of magnetism in the world system. He also explored various relationships between different processes and powers. Organic life, he repeatedly emphasizes, can only be comprehended through its relationships with inorganic nature. In his philosophical investigation of organic life, Schelling was concerned not with the structure of organisms as organized wholes, but with the continuity and relationship of organic functions as the principles of its organization. His concern was not with comparative anatomy, which studies appearances or the external structures of organisms, but with comparative physiology, which studies the inner functions giving rise to appearances, drawing upon the proposal for a comparative physiology presented by Kielmeyer. In Schelling's most developed work on the philosophy of nature, his 1799 first outline of a system of the philosophy of nature, organic nature takes central stage. In this text, he posited a concept of irritability, Reibbarkeit, as the essence of the organism, to make sense of the relationships of organic powers and the boundary between living and non-living nature. Excitability represents the reciprocal determination of receptivity and activity as the dual conditions of life. The action of inorganic nature threatens to destroy organic life, but this influence contrary to life actually sustains life by continually exciting organic activity anew. External influences act on the organism chemically, constituting what Schelling termed the negative conditions of life. However, he distinguished the organic activity from chemical activity. Chemical activity is also duplicitous, but its opposed activity is extinguished in the formation of a fixed product. In contrast, the external influence on the organism that's subject to it to chemical forces become a stimulus to the renewed activity of life. Schelling also rejected appeals to the fiction of a vital force to explain the activity of life as a product, and I quote, of lazy reason. Excitability is physiological and thus traceable to natural causes. Schelling's conception of itself subject and object. As object, it constructs itself under the influence of an external world. But as subject, it constructs its own organic activity, which is not directly affected by the external influences. Within the living organism, its receptivity to impressions is antecedently conditioned by its internal milieu, or its internal sphere of activity. In other words, the organism taken as a whole must itself be the medium through which external influences act upon it. If nature is conceived as a universal organism, assimilating everything for itself, encompassing all within its sphere of activity, no individuality can maintain itself unless, in order not to be assimilated, it assimilates for itself. In this act of opposition, inner and outer are divided for the organism. Its receptivity to external nature is conditioned by its activity against it. Excitability thus provides the means to conceive how an individual organism can hold its own against universal nature, the central problem of a science of life. Excuse me. Schelling derived the different organic functions that Kuhlmeier studied from the concept of excitability. Organic powers are a product of the duplicity that is the condition of excitability. The cause of duplicity is the source of organic powers or organic activity cannot appear directly in the organism. Rather, it only appears indirectly through the organic activity exhibited in the organism as object. As Schelling articulated this claim, the opposed systems, the irritable and sensible, into which the organism is divided, are only the theater of that organic power, the framework of excitability, and not that power itself. In animal nature, for example, oral formation proceeds from organic powers. Thus, the activity of sensibility is present before organs have formed themselves. The brain and nerves are not the causes of sensibility, but its products. The organic function of sensibility allowed Schelling to characterize more fully his main claim that the organism's sphere of activity is mediated by its sphere of receptivity. Receptivity acts as sensibility, the source of all life. Thus, the spark of sensibility must descend into everything organic, even if its existence is not everywhere immediately demonstratable. Sensibility for Schelling is a completely physical phenomena. It is something reverting into the subject of the organism, to quote, constituting the absolute innermost reaches of the organism itself, thus distance from everything hyperphysical. From inner experience, we can know that the sense organs are the conditions of sensibility. But here the organism is given only as objects. Sensibility is the inner condition of organic movement, is only known through the activity of the organism as object. The inner activity of sensibility becomes an activity directed outward, which is manifested as irritability. The organism is in a condition of restless activity, with the equilibrium organic activity continually disturbed and reproduced. Irritability appearing as expansion and contraction of muscles or the circulation of fluids in the organic body. Irritability is the condition of sensibility, for without activity directed outward, there is no activity in the organism, although not knowable in itself, but only through irritability. Irritability passes over into the power of reproduction, the formative drive or Bildungstrieb. Production is completed in a finite product, but it endures after the completion of the product. To quote, the Bildungstrieb, the formative drive, must be an infinite product, an infinite production, at least within its determinate sphere. The existence of organization has to be a constant becoming reproduced. In a word, the power of production must be a power of reproduction. This constant rekindling of the power of reproduction occurs through the constant rekindling of irritability, stimulating the organism to reproduce through nutrition. The formative drive thus acts through the mediation of excitability. As life is not a chemical process, so the function of nutrition is not simply a chemical process. Nutrition produces a heterogeneous organism, which is itself a whole of interrelated systems, with each individual system having its own specific function and unique excitability. The power that appears active in reproduction is infinite in nature. In the organism, this progressive production is either limited to a product producing unlimited growth, as in plants, or goes beyond the product to produce a new organism. In the latter instance, productivity separates into opposite directions. Excuse me, opposite directions, or two sexes, as a new form of duplicity. In the act of fertilization, first sensibility is awakened, then passes into irritability, and finally into the Bildungstrieb. In this way, to quote, the circle of life, the circle of organic nature closes. Or as Schelling also stated, nature will in this way return by a circular course to the point from which it departed. Again, the activity thus endures, for it reproduces its condition to infinity, but not the product. The individual is only the means, the species is the end. Representing the activity of nature as an infinite process of formation, what he terms Bildung ins Unendliche, Schelling posited how at each stage of development, formative nature is restricted to a determinate form. In other words, since each organism is limited to a determinate form, all its activity is directed towards the production and reproduction of that form, and thus the reproduction of organic kinds. Yet in arguing that nature organizes into infinity, Schelling also argued that each determinate sphere of organic formation must itself again contain an infinity. The concept of Bildungstrieb contains both freedom and necessity. The Bildungstrieb is free with respect to its different possible directions within the general sphere of species. External influences determine the organism toward one of those directions. Only thus can the variation of organic kinds over the course of the history of nature be understood. The excitability of the organism presents itself in the external world as a constant self-reproduction. The living distinguishes itself from the dead in that organic existence is not an actual being, but rather a continual becoming reproduced through itself. The recurring self-reproduction of the dynamic between receptivity and activity is not a static equilibrium, but is open to constant variation. A comparative physiology would show all the diversity in organic nature proceeds from nature's experiments in the proportions of organic functions. Like Kielmeyer, Schelling detailed the dynamic stages, series of stages of organic nature through a reciprocal determination of the primary functions of reproductive power, irritability, and sensibility, one predominating over the others in different organisms to present the fundamental laws of life as the basis for a comparative physiology. Each organism is a collective term of these expressions, of these functions, limited within a determinate sphere, a product which, what it is through itself, which is simultaneously cause and effect of itself, means and end. Schelling's conception of an organism constructing itself as cause and effect, means and end, echoes Kant. Kant argued that each organism is self-organizing, forming itself not only with its parts possible only through their relationship to the whole, but also with its parts combined into the whole by being reciprocally the cause and effect of their form. But Schelling substantially expanded Kant's account through his conception of excitability and his engagement with a series of studies of organic vitality and the arguments for comparative physiology, such as Kielmeyer. The concept of excitability allowed Schelling to conceive Kant's conception of the organism as means and ends of itself, without reference to the idea of final causes. Instead, he conceived the organism as constructing itself as at once subject and object, continually becoming reproduced through itself by its receptivity to external nature, being conditioned by its activity against it. The concept of excitability also allowed Schelling to address what is one of the central problems of Kant's critique of the power of judgment, the relationship of our understanding of organisms to our understanding of the natural world as a whole. Kant presented this relationship as an antinomy. The antinomy betrays the conflict between, on the one hand, the maxim to unify the diversity of empirical laws of nature into a single system of knowledge, and to unify natural science under a single method guided by the principles of Newtonian science. And on the other hand, the maxim that recognizes the singularity of organism that require different concepts and modes of inquiry. Both maxims are regular principles for our judgments of nature as a whole. The difference between mechanical and organic concepts is not that the former presents the metaphysically real nature of material things in contrast to the latter. As already noted, both sets of concepts are our intellectual contributions to the understanding of empirical phenomena of the world. Part of the difference that Kant presented in the two maxims is in the difference of determinate validity of the modes of judgment involved in each, which he thus valued differently. Newtonian mechanical science provides laws or principles that allow determinate judgments regarding the empirical phenomena it studies, and even the mathematical formulation of those laws. Kant excluded from such determinate natural science what he regarded as merely empirical inquiries, which only allow judgments of regularities in natural phenomena, from inquiries in chemistry to the study of organisms. But as already noted, by the end of the 18th century, many scientists and philosophers, from Killmeyer to Schmidt, argue that empirical sciences also produce laws of the phenomena they studied. Schelling, like his contemporary, rejected Kant's restriction on what constitutes a natural science. He conceived mechanics and dynamics alongside chemistry, electricity, magnetism, and organic processes as different sciences concerned with different phenomena and offering different perspectives on the natural world through different methods and concepts. Matter, for example, can be understood as a relatively stable mass within a system of gravity. But different material substances can also be understood as having different qualities and can be studied as chemical elements that metamorphose into one another. Schelling offered constructions of the dynamic stages of the inorganic world in analogy to the construction of dynamic series of stages in the organic world, valuing the concepts and laws of both as contributions to a new vision for natural science that included biology and chemistry alongside mechanics. But through the concept of excitability as a reciprocal determination of the organism's receptivity to external nature and its internal activity, Schelling retained the opposition between inorganic and organic nature that Kant presented in such a striking form. In his first outline of a system of the philosophy of nature, Schelling repeatedly returned to the boundary, the opposition and relationship of the living and non-living world that is definitive of life. The text runs through the dynamic series of stages in the development of nature, from the formation of material bodies through chemical, electrical, and magnetic processes to organic powers and functions. But it does not do so in a linear manner. Instead, in the text, Schelling cyclically returned to a starting point to reproduce again, if differently, the processes of natural formation into infinity, or Bildungs ins Unendliche, at different levels or stages of nature. In the first section, he began, apparently at the beginning, with the construction of material products and their different qualities, and then moved on to the construction of excitability and the reproduction of organic forms. But in the second section, he returned to the nature of the inorganic in opposition to the nature of the organic. He began again with the construction of matter, now within a system of universal gravity, and worked through the processes of magnetism, chemistry, and electricity, opening and ending with the interaction of the sun and earth as conditions of gravitational action and chemical action. In the third and last section, he returned to excitability as the highest concept of the interaction of organic and inorganic nature. He derived the primary functions of organic life from this concept: sensibility, irritability, and reproduction. But he ended by returning to the interplay of organic and inorganic nature and the processes of inorganic nature. Schelling thus returned repeatedly to the same concepts, drawing the analogies between them: excitability, sensibility, irritability, reproduction, matter and gravity, magnetism and electricity, chemistry. He recursively ran through these series of process and powers in different parts, with varying details and results, his philosophy of nature repeatedly constructing itself. Organic nature, Schelling concluded, is only understood through its relationship to nature as a whole. If the essence of the organism is excitability, the reciprocal relationship between the receptivity to external influences and interactivity, then organic and inorganic nature must reciprocally explain and determine one another. Like Kant, Schelling cautioned that to explain this reciprocal coming together of inorganic and organic nature through to, quote, a divine understanding is the demise of all sound philosophy. Schelling instead argued that their reciprocal coming together can only be explained from the common physical origin of both, that they are both only one product. That one product is infinitely productive, but that productivity is endlessly inhibited, producing an infinity of products, inorganic and organic, each containing productivity in a determinate sphere. Nature is thus originally duplicity, the mean factor between pure productivity and its inhibition, in which we can never arrive at anything absolutely simple or a final form, but only the nested relationships of organic and inorganic processes. Schelling explored the relationship between the reproductive power in chemistry, between irritability and electricity, and sensibility and magnetism, conceiving the organic as the higher power of the inorganic in each. If nature as a whole is thus cast as absolutely organic, he also argued that the living organism is a contraction of universal nature. Duplicity is the condition of all activity, but the original cause of the primal dynamic juxtaposition, that first spark of motion Schelling emitted, is still not known. He still instead concluded by representing nature and its products as oscillating endlessly between an infinite evolution and infinite involution. Yet Schelling then did not deny the difference between inorganic and organic products. Rather, he viewed sorry, I'm just ending now. That's good. It's not moving forward?
Okay, even more?
No, I wanted to be here.
Okay.
Yes. So Schelling did not then deny the difference between inorganic and organic products. Rather, he viewed the living being as a product in the second power. Organic products are distinguished by a double involution, through which living bodies turn into themselves and generate within themselves a dynamic relation between activity and receptivity, even as they develop an intimate relationship with their environments. Organic nature stands both in relationship and apart from inorganic nature, through life consisting in the continual prevention of the attainment of indifference, resisting stasis. There we go. Resisting stasis and fixity. In his first outline of a system of nature, Schelling presented a framework for a philosophy that would lend wings to science through its ideas, an approach first envisioned with Hegel and Hölderlin in their youthful enthusiasm at the Tübingen Stift, and sketched in the oldest system program, German idealism. Schelling's philosophy of nature articulated a new approach to the study of nature that moved beyond Kant's strictures on science to conceive the natural world as a whole, in which organic nature was to be understood in relationship to the inorganic world and its larger environment. Organic self-formation and self-reproduction exhibited both freedom and necessity. engaging in what Killmeyer termed nature's experiments with new viable forms and functions. Killmeyer's studies of the interrelation of organic powers and functions as a professor at the University of Tübingen provided empirical studies for this epoch of a wholly new natural history. In the German context, biology took shape from the openings to new approaches to the study of organisms and the new conceptions of organic life set out by Killmeyer and Schelling. The older system program of German idealism also envisioned the central place of aesthetics, history, and morality in its reimagining of the world. While Schelling would turn to aesthetics and history in his later philosophical writings, it was Goethe, Humboldt, and Treviranus who more fully articulated and developed their relevance to the philosophy of nature and the philosophy of natural science. Both Killmeyer and Schelling, however, foregrounded the valuing of cognizing life for understanding the natural world as a whole and the relationship of human beings to nature. Thank you.